Hi students, welcome back. All right, so today in the video, we're going to first start by reviewing formulas and then we're going to take some notes over molar mass. So to start us off, what you're going to do on the left side of the notes, so you took formulas on page 24, on the left side of that, when you're opening your notebook, on the left-hand side, you're going to write and answer these questions right here. All right, you do not have to write the questions, you just have to write down the answers. And so right now what you're going to do is hit pause and answer these, but remember, left side of the notes that we took the last time. When you are done, jump down to the video or hit play on the video. Okay. So here we are, 4.2. This is molar mass, all right? So remember, this is a new page. We're opening our notebook and we have a whole new page. So from formulas on to the next page. Again, this is still the right-hand side, okay? We take all of our notes on the right-hand side of the page, okay? So notes on the right-hand side and our review is on the left-hand side. And our reviews we'll go over in class the next time I see you, hopefully. All right, so here we go. Jumping right into molar mass. Molar mass is abbreviated MM, all right? And what it is it's the amount of a substance. And we're going to say in 1 mole. All right. In chemistry, we need to relate kind of apples to apples, if you will, because just like if we were comparing speed limits, right? If we were talking about Canada's speed limit and America's speed limit, and we said, you know, the Canadians can drive 110 kilometers per hour and we can drive 65 miles per hour, that's really not comparing apples to apples. And that's kind of the same thing here. So they came up with this system called the mole, and we'll spend a little more time defining the mole, I believe, in our next video. Okay? On to it. Just kind of some stuff for review. For this section, you need a periodic table and a calculator. So if you don't have that, go ahead and hit pause and come back to it. All right, so atomic mass. Atomic mass, remember, is the average of all the isotopes mass. Or we could just say the mass of one atom. All right, so we're talking about the mass of one atom. For instance, carbon, mass of, the average of it is 12.0107. All right, so where do we find that on the periodic table? If you're using the periodic table I gave you, it is the bottom number. Also, to differentiate it from the atomic number, it is the one with the decimal. Okay, so it's the one that has a decimal in it, so you should be able to find it fairly easily. Now, looking at formulas, we should be able to count the number of atoms. So we have a formula, NH4 parentheses 3 parentheses, or PO4, all right? And what we want to know is how many atoms of each element do we have? So if we look at that NH4 and then we've got parentheses 3, the parentheses is just like in math where it is distributive. So that 3 goes for everybody in the parentheses. So we have 3 N's. And then we have 3 times 4, which is 12 H's. Now, don't be tricked with the P. There's no parentheses there, so it's only 1 P and 4 O's. Okay? Awesome. So, steps for finding our molar mass. So the first thing we have to do is write our formula. That's why that last unit, last semester, was so important. All right? Then we're going to separate the formula into our elements. We're going to count our atoms, and then we're going to multiply the number of atoms by each element's atomic mass. Okay? Then we're going to add them up, and we're going to round to 2 decimals. All right? So we're only going to keep 2 decimals right here, but we save the rounding to the end. We don't round at the beginning. All right? And then we're going to label with grams per mole. So let's see if we can't do a couple of examples here. So jumping right in, our first example is dihydrogen monoxide, or water. So our first step is to write our formula. So the formula for water is H2O. Okay? Now it's a separate formula into the elements. How I like to do this is I like to give a little space between each one and kind of give each element its own little line. All right? And then it says count elements of each atom. Count atoms of each element. So we have 2 hydrogens and we have 1 oxygen. Hopefully you agree with that. We're going to multiply the number of atoms by their atomic mass. So we're going to take H, and we're going to take that 1 times 0.00794, and then we're going to take 1 times 15.9994. Remember, no rounding here just yet. We'll round at the end. So in our calculator, we're going to type 2 times 1.00794, and that's going to give us 2.01588. Sorry, my decimal's not showing up right there. And then 1 times that is obviously 15.9994. And we're just going to add those two up. And we should get, I'm going to write it all down. My calculator wasn't cooperating. We're going to write it all down. We're going to get 8. I'm going to write it all down. So we've got 18.01528. Now we're going to keep just 2 decimals. So we go right here. That 1 looks to the 5. Is it going to go up or stay? It's going to go up. So our answer is 18.02. And we're going to label it with grams per mole. And there we go. Pretty simple process, hopefully. All right, let's try the next one. Oh my, we've got a type 2er. All right, but hopefully it's not too scary. All right, so we've got iron 2 chlorate. So we've got iron, which is Fe. This 2 tells us it's plus 2. And then we have chlorate, ClO3, and it's -1. So we have to do our crisscross. So we're going to have a 2 there, and that's what we're going to be left with. So I'm going to lose my charges there, but there's our formula. So just like last time, we're going to break it into our elements. So the elements we have Fe, we have Cl, and we have O. Notice how I just pulled apart the polyatomic ion into its separate elements, right? Okay. So how many Fe's do I have? I have just 1. How many Cl's? That 2 goes for everybody, so I have 2 Cl's. How many O's do I have? I have 3 times 2, which gives me 6. All right? So we're going to take 1 times the atomic mass of iron, which is 55.845, which is going to be 55.845. And then we have 2 times 35.4527, which gives us 70.9054. And then we have 16 times 15.9994, 6 times 15.9994, and that gives us 95.9964. And we're going to add those up. And that's going to give us 222.7468, but when we round, we're going to get 222.75 and then label with grams per mole. Now, it is very important that you show work, so I know what you're doing. The other thing is, I know it's not super fun to write all this out, but with what we learn in the next video, it's going to make it so much easier. Okay? Thanks. See you next time.